Consider the equation z to the power 4 is 16i. The equation has 4 roots. Question A, find these roots. So the first step is we need this complex number to be in the Euler's form. And if we represent this number on the Argand diagram, it's somewhere here, and modulus, it's what? It's just distance from the origin, and it's clear that it's 16, and argument is just angle from this starting point. In anti-clockwise there are positive angles, in clockwise there are negative angles, and you can see that argument is just what, 90 degrees or pi over 2. Hence this complex number in the Euler's form becomes 16 e to the power I pi over 2. Then we just use the formula, and roots are that k is 16 to the power 1 over 4 because in general we consider z to the power n is equal to something, and e to the power I theta k, where theta k is our argument, pi over 2 divided by n, it's 4, and plus 2 pi k divided by 4 by n. And for k is 0, 1, 2, 3. There are 4 unique roots. It means from 0 to 2 pi, because if you consider k to be equal to 4, you get this root, but argument will be rotated by 360, and you get absolutely the same point on the Argand diagram. And here it is required arguments to be from 0 to 2 pi in increasing order, and it's useful to use such values for k. But if you use 1, 2, 3, 4 to get in increasing order, you just subtract 2 pi from this to get the least positive value of argument. And usually I use notation directly 0, 1, 2, 3 corresponding to value of k with 0, 1, 2, 3. But here notation is 1, 2, 3, 4, so let's use 1, 2, 3, 4, and for the first possible root we just substitute 0 for k, and let's rewrite with theta k with common denominators to be more easier to add them up, and it becomes what, pi over 8 plus what, 4 pi k over 8. So the first root is 16 to the power of 1 over 4, just 2, e to the power I, what, pi over 8, and it's 2 times cosine of pi over 8 plus I sine of pi over 8. It is required the answer to be in modulus argument form, and arguments should be from 0 to 2 pi. And you remember, for any argument you can add or subtract any number of 2 pi in general. So the next root is 2 to the power of 2 times e to the power I, and substituting 1 for k, you can see that it becomes 5 pi over 8, and is 2 times cosine of 5 pi over 8 plus I sine or 5 pi over 8, and this third root for k is 2. You can see it's 9 pi over 8, so it's 2 e to the power I 9 pi over 8, which is 2 times cosine of 9 pi over 8 plus I sine of 9 pi over 8, and that 4, 2 times e to the power I 13 pi over 8 is 2 times cosine of 13 pi over 8 plus I sine over 13 pi over 8. The next, the roots form a geometric sequence. Question B, find the common ratio of the sequence expressing the answer in Cartesian form. So if they form a geometric, to find the common ratio, what is common ratio? It can be found as what, any divided by the previous. So we can consider, for example, z2 divided by z1, and it's 2 e to the power of I 5 pi over 8 divided by 2 times e to the power of I pi over 8, and it's what, e to the power, or just subtraction, 4 pi over 8, or e to the power I pi over 2, and in modulus argument form it's what, cosine of pi over 2 plus I sine of pi over 2, which is what, cosine of pi over 2 is 0, sine of pi over 2 is 1, so it's just I. So it looks like a 0 plus 1i is in Cartesian form as required. The next. The roots are represented by points respectively. On Argand diagram, plot the points. So, and you remember that if we consider z to the power 4, there are 4 roots and they are equally spaced on the Argand diagram from 0 to 360, and it means that there will be 360 divided by 4, it's what, 90 degrees. There will be 90 degrees between any 2 consecutive roots, and modulus is 2, and for the first argument it's pi over 8, it's what, pi over 4, it's 45, and it's just a half, so it's something like this, and these lines should be perpendicular because this angle is 90. And it's A, B, C, D. The next, the equation v to the power 4 is a plus bi, has roots the same but complex conjugate. D determines the value of a and the value of b. So since for example, this is a solution or a root of this, so we can just substitute, for example, z1 complex conjugate for v, and since it's a solution, it is equal to a plus b I as required. It doesn't matter what root can be substituted. Let's substitute, or let's consider z1 complex conjugate to the power of 4 is equal to a plus b. It's because it's a root, it's a solution. If you substitute solution into this expression for v, it is equal to a plus bi. So z1 is what? It's 2 times e to the power I pi over 8, so z1 complex conjugate, it's 2 e to the power of negative I pi over 8, and hence z1 complex conjugate to the power of 4 becomes 2 e to the power of negative I pi over 8 to the power of 4 is 2 to the power of 4, it's 16, e to the power of negative I pi over 2, and in modulus argument form it's 16 times cosine of negative pi over 2 plus I sine of negative pi over 2, and cosine of negative pi over 2 it's 0, and sine of negative pi over 2 it's negative 1, so it's negative 16i. So a is 0 and b is negative 16. The next, the midpoints of AB, BC, CD, and DA are A prime, B prime, C prime, D prime respectively. Consider this equation W to the power P is 2 to the power of Q, where PQ are positive integers. For all the roots of this equation are represented by points. Find the least possible value of P and the corresponding value of Q. So key idea is the next, that if you consider z to the power of 4, there are 4 roots which are equally spaced. It's if we consider the previous equation, our solutions are like this, and there is 90-degree angle between any consecutive root solutions, but it's z to the power of 4. And if you consider z to the power of 8, there will be 8 equally spaced solutions, and there will be just additionally 4 roots, but the previous 4 roots remain at the same places. And that's why question is find the least possible value, because in general you may consider z to the power, it may be z to the power of 40, and it consists or it contains these 4 roots at the same places. So it's A, B, C, D, and it is given that A prime, it's just midpoint of AB, and B prime, it's midpoint of BC, and the midpoint of CD, it's C primed and D primed. And we know that it's pi over 8 and it's 90, so here it's pi over 4 or 45 degrees, and we know that modulus of A is 2, and we can find a complex number corresponding to A primed, and it's what? It's modulus, it's 2 cosine of pi over 4, it's what, root 2 over 2, so it's root 2, and angle or argument, it's what, pi over 4 plus pi over 8, it's 3 pi over 8. So it's a complex number corresponding to A primed. And since there are 4 points, it may be w to the power of 4, but it may be w to the power of 8, because there will be not 4 but 8 points, but A prime, B prime, C prime, D prime will be at the same places. So in general we can say that this complex number corresponding to A primed is the solution of complex number to the power of 4 for n. And let's consider this, because we need what? It to be equal to positive integer. So to the power 4n, it becomes root 2, or it's 2 to the power of a half to the power of 4n, it's 2 to the power, it's 2 to the power of a half to the power of 4n, it's 2 to the power of 2n, e to the power of I, 3 pi over 2n, and it is equal to 2 to the power of 2n times cosine of 3 pi over 2n plus I sine of 3 pi over 2n, and we need it to be equal to positive real. Positive real, it means these two should be equal to 0. And you can see that when n is 1, it's 3 pi over 2 sine is not 0, but when n is 2, it's sine of 3 pi is 0. When n is 4, sine is also 0, and 6, 8, and so on. And we need the least possible value of p, so we need the least possible value of n, and we just check. For n is 2, you can see that it becomes what? 2 to the power of 4 cosine of 3 pi and 0, but cosine of 3 pi is -1, so it's negative, but we need it should be positive. And we consider the next possible value of n. For n is 4, we get 2 to the power of 2 times 4, it's 8, and cosine of 6 pi, which is 1, and we get it's 8, 2 to the power of 8. And it's positive real as required. Hence it becomes for n is 4, hence it becomes root 2 e to the power of I 3 pi over 8 to the power of 16, and it is equal to 2 to the power of 8, 2 to the power of 8. It's actually our w, but it's not required, so p is 16 and q is 8. So again, let's review. There are 4 points which correspond to complex numbers, and each point, each complex number is a solution of this. But since there are 4 points, and we remember in general that solutions roots are equally spaced, and it may be, since there are 4, it may be p may be 4, but it may be 8 and any multiple of 4. Why? Because any multiple of 4, these 4 points, a prime, b prime, c prime, d prime, remain at the same places. But in general, it may be absolutely, it may be raised to absolutely any power, which is multiple of 4. But we need the least possible value. So we need the least possible value of n. And we consider, since a complex number, for example, which corresponds to a prime, is a solution of this, it's actually w, we consider this complex number to power which is a multiple of 4, and consider this, and we get in terms of n, but we need it to be equal to real and positive. So we just choose the least possible n, value of n, so that the right hand side, this, to be equal to real and positive. And to be real, this should be 0, and it's for n 2, 4, 6, 8, and so on. And for 2 we get cosine to be negative, we get real but negative, so it's not what we need. And the next possible value for n, we get that our complex number to the power 4 times 4, 16, and it is equal to the power of 8, which is positive and real and positive as required. So we get that it becomes w to the power of 16, which is equal to 2 to the power of 8, and hence P is 16 and Q is 8. And that's all for this question.